my story is about testability. I think often as testers, we just deal with the problem, we deal with the system under test. But often I think we can actually add value in the design of the system. So a bit about me. I live in the Netherlands with my wife and 2 sons. I have weird hobbies like renovating a house and painting miniatures. I currently live as a strategic software delivery consultant at QExperts. And to summarize what I do is that I help teams to go faster by going better. I think this is a journey that many people can relate to. We once started to automate things, and then automation started to hurt us. Before I talk more about that, I would like to give a bit more of my background. So I am a software engineer, and I started my career in a startup, very lean, very agile, very TDD, BDD, cloud, DevOps, all the things, very great. Some things didn't even have names or books back then, but we were doing it. Great. And then I joined a larger company, and then there were suddenly testers. And I was really surprised because it felt like this is not a place where I would like to develop software, because I write code and then I need to wait for a couple of days before it comes back, before I know whether it's good or not. So this is where I started as a QA lead. I started setting up pipelines, setting up test automation. Because the solution is simple, right? You just shift left testing and more unit tests, things like that. Well, developers didn't like writing unit tests, so we had to help a little with that. But it turns out it's not that simple. But because we did do the automation, really good conversations started to happen. And this is a common theme that I see in many organizations. So we have developing, we have testing being 2 separate activities. But the result of that is that our systems often are not developed to be tested. So hence they have a poor testability. And as I mentioned, as testers, we often deal with that as a given. But actually our tests give us a lot of information on how the system works and why it's not good. And I'll come back to that later. But the result is, if we just keep dealing with it, then we end up with a lot of maintenance nightmare, both in our system and in our test. And I think some things we all can relate to maybe is the test pyramid upside down. So when you have a lot of integrated tests, that's typically a sign that your testability is poor. But there are smaller things you can look at, like if you feel that you're just retrying to run your test suite just to get a green pass, then you're probably doing something wrong. And actually it is a feedback cycle. So the more you add to your system, the worse it gets. Because your tests get more complex, but your system also gets more complex. And the maintainability gets harder. And one of the problems is, one of the things that I learned, it's not just tests are adapting to the system, but the system is also adapting to the test. So if you have a lot of integrated tests, there's actually nothing that keeps your system design from degrading over time. So it's like that's how monoliths appear in this world. If you want to learn more about this feedback cycle, I can highly recommend a talk by J.B. Rainsberger, Integrated Tests Are a Scam. But I think this is something that everyone has, this kind of problem. It's sort of natural. But I think what the good teams do is they know how to break this cycle. And in order to do that, I think we need to train ourselves to listen to the right signals. So we are very trained to listen to our tests in the sense of, does it still work? Validate our requirements. Test passed, good. Test failed, not good. But we don't really, sometimes we just need to take a step back and look at our testing approach to see, did we build it right? Did we build it the right way? So more about validating the maintainability of our system. And you don't always need to quantify, although it helps. But you can ask yourself, is our test still fast? Is it stable? Is it easy to write? Is it thorough enough? And I think if there's one thing in my presentation that I would like you to take away from this, it's this thought. If it's hard to test, we build it wrong. This is a sentence that I brought to my team long back, and it's really hard to disagree with. Developers get it, management even gets it, and it's something you can go back to every once in a while. This is kind of the common ground to get the discussion going within the team. Once you have identified that issue, you can shift the perspective. So it's not a testing issue anymore, it's a testability issue. A testing issue typically is a tester's issue. A testability issue is a systems issue. And you can collaborate with architects or your developers to fix it. But what does testability really mean? I mean, we can all look up the definition, but it's not really helping us, making it easier for us. So if there's a book, Developer Testing by Alexander Tarlinger, where he has this diagram in his book, and it decomposes testability into 3 different areas. One is observability. Great, because everyone wants observability right now. It's in the cloud, and you can monitor stuff, but it's also about exceptions not just going away. So if an issue in your system is really hard to detect, well, then you have an observability issue. The other one is controllability. And I think that's where a lot of the Dockerization and things like that come from. So it's how much control you have over your application. Can I run it everywhere? Can I run it on my machine? Do I have control over the state? Or does it depend on a certain third-party database? And the other one is smallness. And smallness, it almost speaks for itself, but the smaller something is, the better you can test it, because it has a restricted behavior. And actually, this diagram I found really helpful to discuss with developers, because they get it. You could use the same diagram to describe what a microservice is. Or clean code very much resonates with that lower part. So it's not that testability is something that developers don't know about, because beautiful software is often testable. So they will understand. So in short, we have a test approach, we have testability, they relate to each other. And it's not, as I said, it's not just we should adapt our tests to our test approach, but also we should adapt our, we shouldn't adapt our tests to the testability of our system, but we should actually leverage our tests to improve the testability of our system. That was really fast.
Thank you very much.
Thank you.
That means that we have more time for Q&A. So go to your Slido and ask further questions or rate the existing questions. So there are a couple already there. So you got this diagram, and I think the question was arriving a little bit earlier, but maybe you have some comments on that. So that how do you define an architecture which is testable, and how do you formulate requirements for that?
Well, having an architecture makes it testable because it consists of several components, and you can test those components. I think often the problem when a system degrades is when the lines become blurry between those things. So it's really important that if you have an architecture, where there are several responsibilities, is to make that responsibilities clear, so you can test for these responsibilities.
Thank you very much. How did you apply these testability ideas to the existing product? Because I guess when you arrived to this project, it has been a bigger code base already. So, and some of these ideas were more clear or better understandable if you really start from a greenfield stuff.
Sorry, can you
so that what kind of challenge? How could you change the existing product to be more testable? Because did you split the dependencies, or how did you do that?
It's a good question. One of the very important things is where we committed to as a team is that all the automated tests that we do was part of a pipeline. So that when it started to get slow, when it started to get fragile, everyone felt the pain. And that actually sort of forced that discussion forward. So we had to decide, is it a testing issue or is it a testability issue? And to give one example, we started off with doing pixel-based tests. So my team was building enterprise visualization software, multi-billion-dollar product, and all we get out of the system was pixels, which are quite annoying if you have to test them with test automation. It becomes hard to maintain over time. So what we did, we had the discussion, do we really need, in our case it was the HTML5 canvas, can we maybe use SVGs? Because that's more easy to test. It's like a DOM tree, just like an HTML, and we can, instead of verifying pixels, we can ask the DOM how many bars are there in our bar chart, for example.
Super, thank you. So you had some dev background. So was your background helping to apply these principles to the code or to talk to the developers? Or
absolutely. I think my background helps a lot with having the conversation, but it also comes with a bit. Also came with a bit of naivety that I think you need for such a transformation. Because my job was, it felt like my job to make myself replaceable. I didn't want to be in QA, so I like my job in QA, but I always felt like, okay, I should not be necessary, ideally. So that's why I tried to shift back and enable development as much as I could.
Okay, super. So, in which practical applicant ways can other team members, like developer, help with increasing the testability? So do you have some concrete things that you have in my mind that how was this cooperation working, and how did you involve the dev team to make these tests less more maintainable?
Yes, so I think that goes back to my earlier remark. It's important to share the pain. So if a developer needs to deliver code, but he's held back by a test suite that runs for 5 hours and it's fragile, and yeah, they're going to start complaining. And yeah, we just turned that complaining into useful conversations.
Mm-hmm. Super, thank you. This is still not the Q&A timer, right? So we have 5 more minutes. Okay. So, so there are a couple of things like testability of code, testability of system, and testability of architecture. If you would need to make some prioritization, then which one should come first? Or, I mean, it's hard probably, but
yeah, I think of testability as a property of a system, not so much of the code. If you define these different layers of testability, I think you're already defining the layers of testing that you need.
Makes sense, makes sense. Actually, the last one is not so much of a question, maybe just a comment or a parallel thinking that in linear systems theory, I'm not knowing too much about that, they say that if there are unobservable states, then the system will be unstable. And I think that's pretty much going hand in hand with what you said, that observability is a very important. Can you maybe just share some things as how did you improve the observability, or what kind of things can we imagine there?
Yes, so at some point I think our logging was just missing. And I think that's the most obvious one because everyone has logging in their system, most of us. But there were some things that we just could not get out of our logging, and that's what we improved.
Small steps. Okay, so these were the questions. Thank you very much for being here. Please give him a big
Thank you.